All right, a little over 30 minutes late. That is okay. We'll just get right into it. Okay, day 6, tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Starford Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard that you have significant experience dealing with signal-based systems, he convinced the other elves that it would be okay to give you one of their malfunctioning devices. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where 4 most recently viewed characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. For example, suppose you receive the following data stream buffer. I will go ahead and copy this. After the first 3 characters MJQ have been received, there haven't been enough characters received yet to find the marker. The first time a marker could occur is after the 4th character is received, making the most recent 4 characters MJQJ. But because J is repeated, this isn't a marker. The first time a marker appears is after the 7th character arrives. Once it does, the last 4 characters received are JQPM, which are all different. In this case, your subroutine should report the value 7 because the first start of packet marker is complete after 7 characters have been processed. Here are a few more examples. Okay, great. How many characters need to be processed before the first start of packet marker is detected? And let's get our puzzle inputs. Okay, so we don't have to change anything, great. So the naive way to do this would just be to have like a moving window. You could just have an array of 4 elements and then rotate through them. Try to think of a Kotlin-y way to do that. Okay, so what we want is we're going to do for I and input.indices. So indices is just going to give us basically a range of 0, 1, 2, 3, 4, all the way up to the list of the string minus 1. Actually, this needs to be input 0, right? Indices, so that because we only have the first string. So whatever the size is, it goes that. And then what we want to do is max count, I guess, is going to be the input dot substring I to I plus 4. So this is going to give us I plus 1, I plus 2, I plus 3. It'll not give us I plus 4. And then let's just map that to it, which will give us a new list of characters, each one being in a separate element of the list. And then we'll make this real cheeky. We'll just turn it into a set. So as I mentioned yesterday, a set basically has at most 1 of any element. If there happens to be a repeat in there, it just ignores it. And so that's our max count. I should say max count, I should say unique, I guess. We'll call it that, that's fine. And so if unique is equal to 4, we want to return unique.size equal to 4. We want to return I plus 4 to long. So if it was the 0th, because, well, it should be I plus 3, because of the 0 indexed, okay. and then return 0L. Otherwise, and then let's see what happens here. Check failed. Oh, I need to update the check. Check failed. Okay, let's see what it says here. I do not know why it did not debug. Okay. Oh, just never got there. Okay. I equals 3. Oh, so it is going to be. Oh, yeah, because they don't do 0 index for the untouched. Okay. So they want it back in normal index or normal counting numbers. Beautiful. All right, 1287. So let's grab that, and then we'll head back to edit code, 1287, submit. Yay, we got a right gold star. Continue to part 2. Your device's communication system is correctly detecting packages, but still isn't working. It looks like it also needs to look for messages. A started message marker is just like a started packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of the start and message markers for all the above examples. So do I have, yeah, so I got the first one. So I want character 19. Okay. Character 19. How many characters need to be processed before the first start a message marker is detected? Okay, so in this particular case, it's going to be super easy because we didn't do it the naive way, which worked out. We're just going to do a substring of 14 characters. And then they're all distinct, so just 14. And then if unique size equal 14. So just 14, 14, 14. Okay, let's hit the button. Great. By far the fastest one I did, and I did it an hour late. Great. That's the right answer. You're 1 gold star close to collecting enough star fruit. Okay, cool. See you guys tomorrow.